Erik Hoff, and today I will talk with you about my idea on how to track and avoid space debris using CubeSats. As I said, my name is Erik Hoff. I'm also a member of the Wolfpack CubeSat Dev Team. The Wolfpack is an aerospace team located in Florida, composed of mostly middle through high school students. And in 2018, we were the first group of middle schoolers to design, build, test, and launch our own CubeSat. We are currently working on our fourth CubeSat, the Wolfsat 1, where I'm a coder and hardware engineer, and I work on the PCB. We have today launched 2 CubeSats, with a third being planned to launch today, but was sadly delayed. Space debris is a rapidly growing issue. It is a massive issue because it can cause damage to other spacecraft. This poses a great risk to other missions and astronauts. There are also, when these collisions occur, they also create a large amount of other debris, and they also have high cost implications. They also create a lot of smaller pieces of debris. These are even bigger issue because they are not always tracked, but they're not always tracked, but can still cause critical damage. So, what is space debris? Well, space debris are often trash in space, like inactive satellites, spent rocket stages, and smaller pieces of satellites. It can also be dump waste and pieces of trash left by other missions. Space debris is accumulating rapidly, and in the last 10 years, you can see a massive jump in the amount of space debris. This chart here shows the amount of human-made objects in space above the size of 10 centimeters. You can see that in the last 10 years, there's been the appearance of a lot of unidentified space debris, and a lot of payloads have been launched. These payloads will in the future possibly become space debris, and this is also a massive issue. There is also a lot of pieces of space debris, with there being over 1.1 million pieces that are bigger than 1 centimeter. And there's also over 130 million that are over 1 millimeter. My proposal to solve this is the SDS, or Space Debris Documentation System. It will use different constellations of CubeSats and use 2 different classes, this being the searchers and the identifiers. The searchers' primarily role will be mass searching and cataloging basic information, while the identifiers will be used for focus searching on certain points of interest and even possibly deorbiting. All this data will be put into a database on Earth, which will be open to the public and will have many warning systems that will warn us when collisions are about to happen. Our first constellation, the searchers will be used for mass searching and cataloging in this constellation. This constellation will have either 1 or more searchers, with the optimal number being 4. They will be at a 45 and 135 degree inclination and at 875 kilometers. The identifiers will be used for deorbiting and focus searching here, and we'll have 1 or more of them, with the optimal number being 2. These will be at a 0 degree elliptical orbit, with the periapsis being at 500 kilometers and the apogee at 875. The searchers will be 8U, and their primarily way of detecting space debris or using their radars. They will be equipped with 6, which is having a 90 by 90 degree field of view. They will each have a radar range of 50 kilometers, but we can't detect space debris all this way. This will just be maximum range it can detect anything. It would also be equipped with thrusters. These will allow it to deorbit after the mission is done, or they have been detected with a defect, or they can be used for avoiding other space debris so that they get hit and cause even more. They will be at 2 different orbits in any constellation, and it will be the identifiers will be at 24U size and will be used for primarily deorbiting and focus searching. These will be equipped with 1 big radar with a radar scope between 5 and 45 degrees, and this radar will have a 150 kilometers range. It would also be equipped with an IR imaging device that we use to gather data on how space debris looks and can even predict what material it might be made out of. It would also have a normal camera that will allow us to take pictures of space debris, which will be useful. Might be useful data. It will be equipped with a deorbiting laser, which will be an experimental feature, and it will have an adjustable power output. This will allow us to deorbit smaller pieces of debris without damaging them, since damaging them could cause more space debris. It will be also equipped with thrusters, which will be used for the same purpose as the searchers. objects in space decay. This is due to air resistance, and even though they are in space, objects still decay. This reduces their speed and makes them fall into the atmosphere. But they take an exponentially longer time to fall down. And a significant large piece at 800 kilometers could take multiple centuries to deorbit. With this data, we will gather this data using this equation shown here, and this will be used to determine their trajectory, their future orbits, and how much longer they have in space. The database will include the following data points, which the first one being data number, or the B number. These will be assigned to each piece and will make it easier on holding order on what is what. The next one will be the debris material, which will be estimated with infrared sensors and the radars. We will also include the periapsis and the apoapsis, or the lowest and highest points in their orbits. We will also have an interactive service that we can see at what point it is at what altitude. We will also include the size of the debris, which will be determined using cameras and radars. We will also measure the decay rate, which will be measured in how many kilometers an hour we lose every 24 hours or per day. We will use gradual expansion. This is because when we increase the number of satellites per constellation, we can improve our detection rates and slow down the time until we detect either all or most of the debris in a certain area. We will start with one foundational satellite, and we will increase or decrease the number of proposed satellites depending on how well it does. Gradually scaling up the amount of constellations we have will allow us to optimize our space debris monitoring by exploring new altitudes and orbits. We will use lessons we have learned from older spacecraft to improve our technologies and improve the way we use them. How are we not contributing to the problem by launching a large amount of satellites? Well, CubeSats often become debris. This is due to many issues. One of them is their size and that they were never really meant to last that long. My proposed solution is to use thrusters. These can be used to deorbit them, making sure they do not become space debris. When we deorbit these satellites, we will make sure that they land over the ocean and in dedicated satellite graveyards. This makes sure that we do not damage anything or harm anyone. Currently, there's a couple methods of detecting space debris. One of them is the main one is ground-based radar. These have two issues that we plan to solve them. One of these is the limited range. This can be fixed by either building bigger and better radars, but these are also pricier. And the second one is their high cost. Each of these facilities have to be built, with a lot of them being pretty big. They also have to be run and maintained by people. This also adds over to the cost over time. The data from all these radars are put into databases. The main ones being ESSA's and NASA's. NASA's database contains an estimated 55,000 pieces of debris, but only pieces big over 10 centimeters are routinely tracked. When these pieces are detected, and if they are still being able to control, they will be re-entered and make sure that they are landed in certain spots. Or if they are too high up, they will be put into dedicated satellite orbits, which are orbits where only satellite debris is kept. This image here also shows the haystack and HAX radars. We will create a database about space debris so we can reduce collisions between debris and spacecraft and prevent more debris being created. This will also then improve the safety of space travel and make it less likely that we lose something. We also make a CubeSat network with the ability to record collisions in live time. This will allow us to gain more knowledge on space debris and how it is created. So in conclusion, space debris is an issue that must be solved and soon, and the K won't fix it alone. The SDDS can help solve this by detecting and documenting space debris, allowing other missions to deorbit them, or we can either reorbit them ourselves. This will also result in avoided collision and prevent loss of life and failed missions. This would extend our knowledge of where and how much space debris there is and where it is. And we will use gradual expansion to save costs and improve systems as we go. Thank you.